My name is Calvin. I'm in mechanical engineering and I'm doing my second year of my Master's in Applied Science. I'm the team captain of the University of Waterloo Alternative Fuels team, or UWA for short. And we're basically a student team that competes in automotive engineering across North America, a competition called Eco 2, where we engineer a vehicle that was donated to us by General Motors into a vehicle that uses alternative fuels, in this case a series hybrid electric vehicle. My role as a team captain is to oversee mostly the engineering side of things, so anywhere from mechanical, electrical to control, and as well as the business and communication side of the team as well. The biggest achievement we've had is in the redesign of our rear subframe. So this is the component that holds all your suspension components in the back. It's kind of like the rear frame. And we actually redesigned it so that we can incorporate the motor and gearbox in the back for the all-wheel drive system. And we designed the system the frame in second year that worked, and we redesigned it in third year. Using optimization, we were able to reduce the weight of that by about 60%. So it went from 90 pounds to about 40 pounds, which is very significant, especially in a vehicle like this where we're converting it to hybrid electric. Weight is always an issue. We've increased the weight by several hundred kilograms.
I'm the controls team lead, so I'm in charge of interfacing all the electrical and control systems on the car, making sure they function together. I do mainly a lot of programming, a lot of hardware design, a lot of wiring. I'm usually programming in MATLAB, doing some hardware design, kind of figuring out why things are working, doing some analysis, figuring out why things aren't working, that sort of thing.
Currently, I have the task of creating an Android application that is the center stack for the car, which monitors the car status, its critical properties, and it can also affect things like the radio and HVAC.
So a typical day is anything ranging from computer simulation, so we'll be actually using the CAD models of the car to design new components, to actually using a mill and actually machining these components, to integrating with actual sponsors. So if we have something like a gearbox design, we'll be building the mount for that and actually integrating with the design engineers at those companies, to actually taking the car out for a media event. Competitions are awesome, so they're actually built into two different components. So the first component will be a week of actual dynamic events. So there'll be all 15 cars will be lined up in a garage, and we'll be doing things from 0 to 60 times to braking times. And the second week's all presentation based. So we'll be doing a presentation on the simulations that we've done throughout the year, and then also media stuff. So then people get to actually do ride and drives with the car and actually integrate with it. And then we actually get to see the consumers and how they think our car has actually been done over the year. So there's multiple components in the back of the car. The biggest one probably being the battery pack. So we have an 18.9 kilowatt hour battery pack, which helps give us our all electric range. There's also different components like our charger. So it converts the AC power from your wall outlet to DC to be able to charge the battery pack. There's our DC-DC converter, which we use instead of an alternator on our hybrid vehicle. And a couple other components like your stock components like an amp and stuff like that. So our engine's actually a 2.4 liter flex fuel engine. It's from a 2012 Chevrolet HHR, so it's not actually stock to the Malibu, but it's flex fuel capable, so it can run E85. And a unique part of our architecture is actually it's a series plug-in hybrid electric vehicle, so the engine doesn't actually turn the wheels. It's just belt driving a generator, which then generates the power that can recharge our battery pack.
With our transfer case, we have a bearing which needs to be covered up so that we could give it some oil so it doesn't seize up. And so right now we're experiencing some leaks. So we're trying to figure out what it is, try to cover it up, put some sealants, put some silicone, but unfortunately that didn't work. So now we're going to our last resort, pull it out, take a look, see what the problem is, and fix the issue, put it back in and put everything back up into the car. So it's pretty much what it is, just look at issues, find a solution, put it back in, and hopefully it runs properly. Since I'm pretty new to this, there's obviously things that I wouldn't understand, or I don't really know what the application is. So that's the first thing I try to figure out. What it is that it's doing, why it shouldn't be doing what it's doing, so that I have the benefit of understanding what it is and knowing the application. So that's definitely the first thing that I go for. And then I try to look at the solution, see if what other people tried, if there's any people who tried it before me, so that I don't repeat their mistakes, right? Gather their knowledge and just put them together and try to come up with newer solutions.